Hey Code Websters, welcome back to another video in our series to build a neural network. If you don't know where we are, click on the above pop-up and start your journey. Today, we're going to task our neural network to finally do something interesting. Essentially, we'll input a picture into our neural network and it will decide what type of number this picture is. So we'll use 0 to 10, right? We'll use 0 to 9. And it'll analyze which digit we've actually imported into our system. So let's get right into it. First, we need to import some packages which will help analyze our images. It's basically the same packages, but we're going to add something else, which is pillow. So let's go ahead and do that. Go back to our file from before. Get these. We're also going to go there. And we're going to go from pill import image filter. All right, so if this isn't grayed out for you, it probably means you don't have the pillow package installed. So what you're going to do is you're going to type into your command line or wherever your Python is set up, pip install pillow, just like that. And that should do it straight ahead. I've already done that, so there's no need for me to go back and do that. Now, we're actually going to copy our class from before. So let's go back to what we did before. And this is the beauty of Python classes. I don't have to redo anything. Let's go ahead and copy that. Control C, Control V. So we already have our neural network that we built from last time. Okay, our images will be 28 pixels by 28 pixels, right? Which is pretty small. But we can assume thus we're going to have 784 input nodes, 28 times 28. And we'll set our hidden nodes to be about 200 for flexibility. So let's go ahead and do that and actually start a network doing that. Okay, so just like that, we've created our neural network. Now, we have our output nodes here, which is going to be 10. You might be wondering how exactly that's actually going to work. So let me try to explain that in a bit more detail. Essentially, our neural network will output a probability for each index in an array, right? So we'll have an array, so we'll go 0, 0, 0, up to 9th spaces, right? Or up to the 10th level. Okay, so the zero space will obviously represent our zero probability of an image. So what image that is it a 0 digit? The next space, which will be the space 1, will depict the probability of having 1 in our actual inputs, and the next one 2, and so on up till 9. You might be wondering, hey, so how does that actually work? Well, obviously, we will have our input nodes. We'll input 784 nodes, and those will have some certain characteristics. We'll have our hidden nodes, which will kind of bunch that down a bit for flexibility. And then finally, we'll have our output nodes. At each level, a little bit of the complexity is installed in each layers. Okay, and this will be explained a bit more in detail when we actually tackle convolution neural networks, which will be a future video. Our learning rate 0.3, we can change that, and we'll change it depending on how good our system actually is at describing pictures. Okay, so next we actually want to get our data, all right? So we're going to actually open our file and store its contents. So we actually need training data. I'll show you how to install it, but there's a CSV file in the description. It will be the training data we're going to be using. So let's go ahead and load the training data. Okay, so what we essentially did there was we opened our training data, we read those lines, and we stored it in the data list, and this is where our information is stored, and then we closed the file. So it's kind of like you click on a file, you open it, you copy it, and then you delete everything. Well, you don't delete it, but you close the actual file, so that won't hamper our future programs and take our memory away. Next, we actually want to use this data to train our network. So I'm going to go ahead and do that, and then go back and explain what each line of code does. Okay, so let's try to actually explain what I'm doing here. So let's remember the 0th place in our Mnist data holds the actual value like 7, 8, 9, 1, or 2. We'll ignore that and take the rest of the values. So first of all, we actually split all our values up because it's split through commas, and we'll actually combine that into an array. All right. From there, we want to actually get all the values. All right, so all values, 1 and continuing, ignoring the actual identifying number. We want to scale that, right? So we've scaled it. We've divided by 255 because there's 255, right? There's just an arbitrary number. And we times that by 0.99, okay? And then we plus that by 0.01. This is done because we're actually using a sigmoidal neural network, and our values for a sigmoid, as you remember before, actually go from 0 to 1, okay? At 1 and 0, you're either dealing with infinities, so you never actually set that. You never set an input to be 0 because it's impossible. So what we do is we change our inputs, we scale our inputs, and then we add 0.001, okay? So you might have 100, right? We divide that by 255, times it by 0.99, and then we plus 0.01. Then we get our targets, okay? So initially, our targets are obviously our output values that we want to get. We set that all to be 0 essentially, but our targets, obviously, as I explained before, won't actually be 0. They'll be 0.01, which is essentially close as to 0 as you need it to be. And then what we're going to do is we're going to get the 0th value of all values, right? Because the first placement has the number we're looking for. And we're going to set that probability to be 0.99. Now, I have to stress this. We don't use 0 or 1 because they refer to infinities in a sigmoidal subspace. So, as a recap, we change scale all our values to be in between 0 and 1, obviously not 0 or 1. We get our target values, what we want it to be. We set that all to be 0.01, which will be our smallest values. We set the target value we want to 0.09, train our system, right? And then we just print loading to show that it's not stuck somewhere. Okay, so next what we want to actually make this do is we want it to be able to guess our handwriting, right? So I want you to go ahead. I got MsPaint here, all right? And just, you might not have it at this size. So if you press resize here, change it to pixels, you can go 2828. You can take out maintain aspect ratio, and I'll help you do that, okay? I'm gonna write a 4 here, okay? Just a 4. And I'm gonna save as a 4, okay? 4. So we're gonna go ahead and go to my, I don't want to show you the stuff in my files, but we're gonna go ahead and go to YouTube. Nope. Projects. YouTube project. All right, I don't see anything here, but I'll just save it there. Okay, and it should pop up here. Let's check. Yep. So we've got our 4.png there. All right, so now what we actually want to do is we want to, now that neural network has been trained and everything, we want to test that out, right? There's no need, there's no use, otherwise it would be a useless endeavor. Okay, so we prepared our image, okay, and I'll explain what we do there in a second. We set the record, right? So we go, hey, let's make a record, a specific record, which combines the label, which is 4, and it combines the image data. So similar to how the Mnist or Mnist Data is set up. We'll set our own data set to be empty, and we'll append that record. The reason we do that is we can actually have several tests at once, and I'll explain in the future how we can do that. Okay, guys, so now we want to actually find out what this image prepare function is, all right? In the future, I might explain in more detail how I'm going to prepare the images, but essentially I'm just going to copy and paste. I know you guys hate that. Copy and paste the function, which will be linked in the description, which will just prepare our images for us. Essentially what it just does is it converts the size of our image to 28 pixels by 28 pixels, okay? Okay, everybody, I've just pasted in that system. So it essentially changes our image into a 28 by 28 array. It also resizes the images so it suits our input system. So I've done that and everything should work there. Once again, it's linked in the description. So let's go ahead and we will test what our system actually is. Okay, so that actually tests our system, prints whatever outputs we need. We also next just want to get the highest probability output, so we don't have to actually go checking manually. So let's go ahead and just do that. Okay, so what we have here is we're going to actually print the highest probability value, and we say, hey, the computer thinks it's X, and we're also going to output the correct answer, which is stored in our own data set. So let's go ahead and run that. We might get some errors, but I'll show you how to fix them. All right, so we seem to have an error. Can't import image filter. All right, up here I have an error. So it's supposed to be image filter, not imag filter. Let's run that again. No such file is there. Oh, I forgot to download the file. Okay, I'll be right back, but you should also have your file, mnist.csv, and just place it actually in the same directory as whatever the picture is or the rest of the files are. I'll be right back. Okay, guys, as I've said before, I've just got a Mnist train data right there. Let's see if that works now. It might take a bit because it is running through a lot of points. I think it's 60,000. Hey everybody, I'm right back. Unfortunately, I made an error. Sorry for doing this. I guess I could edit this out, but you know what? I'm gonna make you guys suffer as well. We're gonna do this together. We're suffering together. This is supposed to be 4.png. I wrote 3, which was my error because I was doing it for another one. Let's see if it works again. What we see here is our network says whatever the value we got, 4. All right, so it actually shows a probability. Here's the array, right? So 0 to 9. If you go down to the 4th position, which is 0, 1, 2, 3, 4, it's actually got a 95.7% value. So the network says at the highest probability, this is a 4, which is really good. Now you could try this with whatever system you want, and it actually works really well. So yeah, guys, I think that's our network. It's been done. All you really need is Paint and to watch this tutorial, and you can have a computer that can instantly analyze your handwriting and tell you to a certain probability what number we're working with. You can put different numbers, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, and it will give you a good probabilistic outcome. Now, next week, what we're going to try to do is we're going to do everything in our tutorials so far in literally, I'd say 10 lines using something called TensorFlow. You guys are going to be mind blown. It's a lot better to use TensorFlow because all the models are created by really smart guys and gals, and it can work a lot faster. And you can also save models so you don't have to rerun this shit like 50 times. You don't have to wait a minute for each run. Although I must say that depending on your computer, I'm using the CPU. If you had a GPU, it'd be a lot faster. But yeah, hit that subscribe button, and thanks for being here today. Goodbye.